Question number 9. Now in this question, we need to find out the time complexity for this method over here. So we have two methods over here. So in the second method, we are calculating the Fibonacci of any given number. Then in the first method, we are looping through the numbers and printing out the Fibonacci value of that. So we need to find out the time complexity for this. Now here, one more time, I want you to pause the video and think that if you can come up with your answer. Alright, hopefully you have found the answer. If not, let's do it together. So let's start with the second method. As you remember, we have learned that if a method calls itself twice, in this case also you see that it's calling itself twice with different parameters, then we have found that we have an equation like this. So based on this one, we can calculate our time complexity. So here the number of branches is the ones that the function calls itself. So here you see that function calls itself twice. So this means that number of branches is 2. And depth, it depends on the parameter over here. So our parameter is n, so it's going to be all 2 to the power of n. Now here, many people will rush to conclude that since this method, Fib method, takes all 2 to the power of n time, then this is called n times here. So the time complexity for the first method will be O n multiplied with 2 to the power of n. So you don't need to be in rush, because the point here is n is changing. So that's why that's not going to be the time complexity. Now here, to identify the time complexity, let's see how this is working for each parameter. Now if we call this Fibonacci method for the parameter of 1, it's going to be like this. Number of steps will be 2 to the power of 1. Then if we call it for parameter of 2, then it's going to be 2 to the power of 2. Then we continue like this until we reach n. Now you see that if we call this function n times, so we need to take the all sum of these steps over here. So this means that Fibonacci method is getting called n times inside over here. So if we sum up these ones, we will get the time complexity for this. Now from the math, we know that if we are calling powers of 2, the equation is like this. So with this equation, we can calculate the sum of the power of the 2. Now if you calculate this equation and we are eliminating non-dominant terms, so it becomes all 2 to the power of n. So here you see that even though we are calling this method n times, the time complexity is not n multiplied with this one. So the time complexity is summing up all these steps. So because at each step, the number of steps differs. So that's why the time complexity remains O 2 to the power of n. So hopefully you have understood the logic behind this question over here. So this is a tricky question, but you don't have to be in a rush. You need to think very carefully. So that's all for this lecture. So see you in the next lecture.